Hello, it is the start of the next day. This is the part 2. Because there's more than part 1. I needed to come up with a solution to attach these speakers to the Wait, what was that? Hold on a second. Are you seriously telling me you're bleeping me every time I say What? Stop that. I can say Fine. You know what? I'll just show you. Let's see what you're gonna do about this, Mr. Editor. Yes, hello. So I'm talking about a couple of Really? Well, apparently I'm not allowed to say those things associated with October that you make pies out of, and you carve them into jack. Oh, now that's just... I needed to come up with a way to mount this to the side of the thing I'm going to hollow out. So in order to mount these into the thing I'm going to hollow out and carve, I designed an anchor that is supposed to fit through this hole and then expand when you put a pin into it, shown here. It all looks well and good, but to fit through this hole it ended up being kind of dinky. And on top of which, let me zoom down to this. On top of which, you may notice this pin doesn't give you a whole lot of deflection. If I do it from the other side, there's actually a fair amount of deflection here. I'll see if I can illustrate this and try and hold it still, and I'm probably doing a bad job of that. So that might give me some bite. But why reinvent the wheel? It occurs to me there's already a solution for this. Now, I've had these for a while, but it made me wonder what would happen if I tried to insert one of these into the orange thing and screw in the speaker. So the first thing I need to know is if this screw will work for the speaker. It's catching a little bit on the lip. Oh, actually, yeah, no, maybe if I... It's a pretty close fit. I think it's good enough for what I'm doing. So now the question is, what happens to one of these when I try and put it in the fall orange gourd? I have 2 of them currently, and I picked out some nice ones that'll be perfect for this project, or so I hope. Wow, that takes some force to get it in there. It may be worth going to get a 3rd one for testing purposes. These little carts are my favorite. Alright, now we can grab ourselves a test. Really? Alright, so I want to find one of these large enough, preferably with a flat side on it, because the 2 I have a flat side. That's not bad. I think one of the wheels has a problem. Alright, and a little trick we can use to keep our from going bad is... Dang it. Well, this one's gonna smell good. We can use petroleum jelly to seal the and then it won't wither and dry out as fast. It'll last us a lot longer. You know, I'm gonna grab one of these so that I'm not just trying to do it with my mind, I tell ya. Oh. Ooh. Alright, so we've come over into Fusion because we need to 3D print a part in order to test on the orange thing. In here we can see currently I have my last design, which the design was decent, but it ended up being too small. So we're gonna start from scratch here. According to the anchors I have, these are number 10s. And it says for a number 10, it can hold up to 46 pounds or in concrete 200 pounds. It doesn't, oddly enough, give the specification for orange gourd. But it does say that the hole we want to drill is 5/16 inch. So what I want to do is I want to make a tool that will punch out a 5/16 inch hole. So let's create a new sketch. We'll create it on the top plane. and 5/16 inch, which is apparently 46.132 millimeters. I didn't do the conversion ahead of time. That's what I get. Alright, so we want to make a tube based on that, but I also want to have a bit of a taper. So I'm going to do another circle. I'm not going to sketch a dimension. I'm not going to give it a dimension, because I am going to sketch a dimension. This is effectively how thick I want the tube to be. I usually go with 2 mil. Let's see what that looks like on the calipers. I am going to go 1 mil for this. So 1 mil. We can finish our sketch. Then I'm going to select this ring in between the two, and I'm going to extrude that. I need to make this long enough that I can hold on to it. And I should also make a plunger for pushing the gourd core out of it. So we'll go 75 mil. That doesn't seem right. Let's go back into that sketch, because I have a feeling this dimension is wrong. 5/16 inch. Doesn't like that. Hey Google, convert 5/16 inch to millimeters.
0.3125 inches is equal to 7.938 millimeters.
Thank you. And we zoom in, we still have our wall thickness, we can finish sketch, and hey, it's updated our tube. Now that looks a bit more realistic. I'll add a little area for holding on to it, so to do that I'm going to create a new sketch up there. Again, we'll just do undefined hole, and we will sketch a dimension from there to there. Let's make that 5 mil. Finish the sketch, and we're going to extrude that, but we're going to do that 2 sides. So the bottom side we probably want, I'll go 5 meter of interference. I really only need the bottom side. Join it. So now we have our little tool here, except I actually want to make the bottom sharp. In order to do that, we're going to create a chamfer. Alright, we made the thickness 1, so I should be able to do a 1 millimeter chamfer on that. And I'm going to do 2 distances. So on this upper one, we can make it a bit taller. I'll go 5 mil. So now we've actually got a cutting surface there, and the reason I chamfer the outside, it's going to push out the walls of the as I push through to get the right size hole, so I know that hole will fit, but then when I pull it out, it should sink back in a little bit. And that should, in theory, give us a bit more hold on our anchor. Now I'm going to do a fillet up here, because this looks kind of butt ugly, so we'll just bring that in a bit. Sure, we'll leave a bit of a flat spot to it. It's our plunger. Okay, I know that got bleeped out, but it was alliteration, and it sounded cool. Let's head over to our tools. We are going to make that, and we're going to call that... Really? If you want to put this much work into censoring, then whatever, all the power to you. Next thing we're going to do is we're going to hop into Simplify. You can see I've got my previous one up here. We're going to delete it. Really? Yeah, fine. Load it. Now, I could turn this up. I could give this, should be a negative 90x rotation. No, it was a 90. I could print it this way and it would print fine. However, when it gets to the area up here, it's going to have a lot of trouble printing that. There's going to be extra material. And also printing this way, it's going to make these layers are going to break really easily. So instead, I am going to print this lying down. I'm going to center that up, and I'm going to raise it up 2 mil, should do. Alright, we're going to add some support material to that. I don't want it creating supports down the middle. I know from experience, the middle of this will actually print pretty fine without supports, so we can get rid of that. There we go. I'm going to add a few more on the back. So, there. Probably a few more there. And there. Let's generate our file. Generates nice and quick. That's an interesting profile it ends up printing. You know what, I am going to put a bit of support material at the edge there since it's doing that. There we go, that should do. We hop on over to our print software. Alright, the printer is beginning to warm up. We will come back to this once it starts a print, and